Hello Marcus, this is like the third try me trying to do this, but we're gonna go for it anyways. So put the following in order from least to greatest. There are 4 different starters, and so all we need to do is find the least, the smallest for this first question. Sorry, I'm using OBS to block it out. I couldn't find the online PDF. So we're gonna use the trigonomic identities thing that I showed you. So, and hopefully you have a unit circle. If you don't and you're watching this at that moment in time, text me and I'll send a picture over my unit circle. So we're going to start off with simplifying sine pi over 6 on the unit circle. So if it's sine, we're looking for the y value, and sine pi over 6 is 1/2. So we'll keep that in mind. And then our second one is cosecant pi over 6. Cosecant is 1 over sine, or 1 divided by sine. And because it's pi over 6, we're dividing 1. It's going to be 1 divided by 1/2, or it will be 1. It will be 1 times 2. I'll write this out for you. 1. So if we know the first one is 1 over 2, and then it's 1 divided by 1 over 2. Essentially what you're doing is that 1 over 1 times 2 over 1, because you're dividing it. So cosecant is equal to 1. Cosecant is 1 over sine. So if our sine value is 1 over 2, all we're doing is 1 over 1. We're flipping this around and we're multiplying it. So this would be 1 over 1 times 2 over 1, which is equal to 2. So then what we're going to do is move this down. We have 1/2 to. Our next one is secant 4 pi over 3. So again, if we're looking at the card, secant is 1 over cosine, so the opposite of cosine. Or I'll write this out for you. 1 over cosine. And if we're looking for cosine 4 pi over 3. So find 4 pi over 3 on your unit circle, and then look for the x value. So the cosine value is negative 1/2, but because it is secant is 1 over cosine, it now becomes 1 over negative 1/2, which again, we went over this this is like the previous thing. This would become minus 2. So now that we know it's minus 2, we could probably guess, and then the last one is cotangent. And again, if we're looking at our identities, we know cotangent is x over y because it is tangent flipped. So now what we're looking for is cotangent, what is that? 5 pi over 2. Cotangent 5 pi over 2. So 5 pi over 2 it is larger than 2 pi, so it goes around, wait, is it? Yeah, it is. So it goes around 4 pi over 2 is 2. So it goes around once already, so we can ignore. So 5 pi over 2 minus 4 pi over 2. This is the original value, and this is a full circle. So this is why we're subtracting, so we can get pretend. So now we're stuck with 1 or pi over 2. So pretend that that's not this 5 pi over 2, it becomes pi over 2 because you already go this is one full circle. So now we're looking for the tangent value, or we're looking for the x over y of pi over 2. So we'll take a look at our unit circle. And we know that pi over 2 is 0, 1. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this is 0. And then we know that C is the answer because minus 2 that we solved. Where did we solve? We solved over here. We know minus 2 is the smallest answer, so it would be C. Next question. Oh, we already went over this question. I'll go over it again. So, which of the following points is on the graph of f negative 1? Even though we're not going to be allowed to use a graphing calculator on the test, I'd like to just show you what this is. And so, f of x, this is what a cosine graph is equal to. This is a cosine graph. Right, this is a cosine graph? Yeah. So our given is that f of x equals to cosine. Which of the following is on f negative 1? This just means that we're inversing it. So f negative 1 x. I don't know if this is really going to work. Okay, that's not going to work. So what we'll do is f over x equals to excuse me. No. Okay. Whatever. Pretend the x. I don't know how to flip the x and the y. But pretend the x and the y. Okay, whatever. So pretend the x and the y are flipped. So we're solving for is the domain. We know the domain of the normal is the top point. Or actually, domain is all full numbers technically. Is it? Are we gonna do that? Or oh no, we're doing 1 period. Okay, we're gonna call it 1 period. So 0 to 2 pi. That will be, but now that we're flipping it, it'll be. Excuse me. We're flipping that. That will be our range. So our range would be 0 to 2 pi, and then our range, our lowest point is our domain now. So it's negative 1, 1. And so now we need to look for, is this in, are any of these in? Okay, so is pi over 4 in the domain? Yeah. Is it in the range? Yeah, but can we find this? Let's see, where's pi over 2? Yeah. Pi over 2. Where x equals to pi over 2. Excuse me. Alright, pi over 4. We know that with pi over 4 and root 2 over 2. Let me solve that for you. Root 2. That's on this one. So no, that's on here. X will go. This is hard to explain without showing the graph. But this is out of, C is out of the range. C is out of the range. So C, we know A and C aren't it, and D is D out of the range. What is our range? our range is out of the range. It's negative, and our range is 0 to 2 pi. That's out of the range. No, not on the graph. Can't be it. Okay, so we know B is the answer by process of elimination, or you could technically graph it, but I just don't have the means to do that right now. Okay, our third question. If sine over here, find cosine, find secant, 0. Okay, again, we're going to go take a look at our, whatchamacallit, our identities thing. So I'd just keep that on you, like pull up a screenshot of it or whatever. But if sine theta is larger than 0 and cosine theta equals 2 over 3, find secant theta. So we know if we look at our identity, our reciprocal identities, we'll figure out that secant is 1 over cosine, or cosine flipped. So if we're flipping cosine, and cosine is 2 over 3, and you flip it, I can write that out if you're a visual learner. Cosine 2 over 3, cosine is equal to so then you flip it, it turns into 3 over 2. That will be the answer. Next, we're moving on to 4. Which of the following statements is false? Y equals tan x and y equals cotangent x have vertical asymptotes at the same x values. Y equals to cosecant has a range of negative infinity to negative 1. There's a space in between, and then 1 to infinity. And y equals cotangent has a period of pi. It's a period of pi. And y equals sine x and y equals cosine x have the same domain and range. So we'll start from A. Y equals tangent x and what is it? Y equals tangent x and y equals cotangent x. Damn. Do they? What did they ask me? They're asking, do they have the same vertical asymptotes at the same x values? Is this true? Oh, okay. So we know there's a vertical asymptote here, a vertical asymptote in between these two, but if we turn on tan x, it goes through, so it can't be A. But we'll still go through each answer choice. Y equals cosecant has a range of negative infinity to negative 1, and then 1 to infinity. So range is, again, the y value. So what we'll do is we'll put it in the Desmos graph. And would you look at that? They're both parabolas that go to infinity, and there is a space in between negative 1 and 1. So it can't be B. Y equals cotangent x has a period of pi. So for tangent graphs, there's a special rule. Tan theta and cotangent theta, they have a special rule where it's both pi over 2 plus pi k. So this is the rule for vertical asymptotes. We can see this in tangent graphs. If you graph it, you can see it in cotangent graphs. If you graph it, we'll graph a cotangent graph right now. And pi over 2 plus pi k. Y equals pi over 2 plus pi k. Well, pi infinity. It just means pi k means it repeats infinitely. So we know that it can't be C. Okay, D. Y equals sine x and y equals cosine x have the same domain and range. This one is pretty self-explanatory. And if you just graph them, do they have the same? Oh, y equals cosine x. While they may not align, they do have the same peaks, and they both go peaks in like absolute minimum, absolute maximum, and they both go on for infinity, so they do share domain and range, this same domain and range. Okay, for this next one, use trig identities write each expression in terms of a single trig identity. I'm gonna go and practice this. Okay. Y minus cosine squared x over tangent 2 to the x. So if we look again at our identities, trigonomic identities, we will look around, we'll look and look around until we find one that matches what says up there. And if we go to the Pythagorean identities, we know we can figure out that sine squared theta plus cosine squared theta equals 1. So in turn that means cosine squared theta equals to 1 minus sine squared theta, and vice versa. And we'll remember this. This is very important to know, especially for this problem. Cosine 2 theta, so 1 minus, that's, if we look at it, it's this identity. So now we can rewrite this into sine squared theta over tangent to x. And because this is cotangent, well, tan is at the bottom, and y over tan equals to cotangent. Again, if you look in the reciprocal identities, it'll be there. The thing literally has everything that you need to know. So if it's like this, then that means x is at the bottom, x is at the top, or cosine. Let me grab this. Cosine is at the top, and sine is at the bottom. So you rewrite this, turns into sine squared theta cosine squared theta over sine squared theta. And then you cancel these two, because it's sine. You get that? Because they're both sines, you can cancel them, which leaves us with cosine squared theta over 1, which would be your answer. Okay, next one. Here, I'm gonna send you a video for each page. There's 3 pages. I'll have to get a cough drop after this or something. So 1 over 1 plus cotangent squared theta. Okay, it won't be a shocker, but I'll tell you. But again, if you look in your Pythagorean identities on your trigonomic identity sheet, the white thing that I sent you, will figure out that 1 plus cotangent squared theta is equal to cosecant squared theta, which in turn means that we can replace this with 1 over cosecant theta. And now if you look at your reciprocal identities on your trigonomic identity sheet, I'll just call it the white sheet from now on. Cosecant is equal to 1 over sine theta. Now, if this is 1 over sine theta, again, this is gonna seem crazy, but 1 over 1, and these get flipped, and you multiply. Sine squared theta over 1. So, and then voila, you get sine squared theta. Just say that? Yeah. Alright, last one. Or actually, there's another question after this. So, cotangent. How did I solve this? Cotangent to theta 1 minus cosine. Okay. So do you remember, where does it go? Oh, over here. Sorry. Let me drag this over here. So I just dragged this. This is these important identities. Again, they're on the white sheet in the Pythagorean identities, and they're just this is like really important. Okay, so cotangent squared theta, then 1 minus cosine. 1 minus cosine, where is it? Sine squared plus cosine. No, we want it to. Okay, 1 minus cosine, which is equal to sine squared theta. Okay, now that we know sine squared theta, let's look at cotangent. That's in reciprocal identities. Oh, what is that? Well, I mean, it's cotangent and tangent are opposites. So that's 1 over tangent. This is so stupid. 1, 2, tangent, times, you don't need the 1, you can turn to make this sine squared theta. And okay, now that we have tan at the bottom, what are you going to do? The tan wants to come apart. So again, you're going to flip it, and if it's at the bottom, cotangent equals to cos over sine. So this is important. Sine, because cotangent over here. Oh, actually, I probably should have written it like that. Cotangent. Oh, wait. So this is cosine squared theta times sine squared theta over sine squared theta, and you'll cancel sine squared theta, because again you're dividing sine squared theta by sine squared theta, and what you end up with is cosine squared theta. That will be your answer for C. Okay. Oh, this one is. Let's see. Which is the next problem? Which of the equivalent? Which of these is not an equivalent function to f of x equals sine 2x? Okay. This is gonna seem crazy, but I'm going to tell you to look again at your white sheet, which has all of this information. So if you look at your white sheet, which one is it? Specifically the double angle identities. We learned that sine 2 theta is equal to 2 sine cosine. And so we learn A is not it due to the double angle identity. B, sine 4x. Okay, well, I mean, this is stupid. You're not supposed. If you're gonna subtract, it has to be within. So we'll graph it. I'll show you the graph, just to show you that this is blatantly incorrect. Yeah, look, this looks crazy, right? This crazy graph is y equals 4x, or sine 4x minus sine 2x. Looks crazy like that, right? So the black is a normal 2x. They look nothing alike. That's not it. You can't subtract like that. Our next one is g of x equals sine 4x cosine 2x minus cosine 4x sine 2x. That's a handful, but if we look at the sum and difference identities, I'll write it out. The identity that we're going to look at, sine a plus minus b equal that weird Greek thing. That's just a b. You don't have to worry about that. And so 4x, 2x. What that's saying is subtracting. If we look at our identities thing, the subtracting is at the bottom, so when you subtract for sine. So sine 4x minus 2x is equal to sine 2x because you're subtracting the x's in its parentheses, not outside. And then the last question, again, it's the same thing. You're subtracting the x's, sine 5x minus 3x in the parentheses, so you are allowed to do that. That is just, it would again become sine 2x. Alright, lastly, how many equations is oh wait, this is the one we went over in class. Okay. Negative 5 equals to 3 sine x minus 3. We went over in this class, I'll go over it again for you. Again, combine like terms, so this minus 3, it's not in the parentheses in the question. You bring it over, you add 3 on both sides. So this comes minus 2 equals to 3 sine x. And then from here, you can divide the 3, it's 3 sine x, 3 times sine x technically. You divide the 3 on both sides, which will then become minus 2 over 3. Oh, I'm sorry, I'm probably going a little too fast for you. Minus 2 over 3 equals to sine x, which then you can plug arc sine. And we're plugging arc sine because we're reversing the equation. So sine negative 1 minus 2 over 3 equals to x. And then you get minus x equals to negative 0.729 blah blah blah. And that should roughly be over here within the graph. So it's negative 5, this would be 5, or whatever. I don't know how she wants to format this. But it'll be roughly here because it's within the fourth quadrant. I don't really know how to explain the quadrants, but it's over here. Here, is this a good example? We'll do this. Yeah, whatever. And so we can also, we're allowed to go within these grounds, but nothing over. So well, you cannot go over here and make the opposite. That's not allowed because you're only allowed within this part, okay? So instead, you have to go from here to make the opposite. So it'd be negative pi minus, and then minus 0.729 or 7.3, whatever you want to abbreviate it to, and then that's how you solve it. But we know there's 2 answers available, so that's C. This is the first page. I'll go over more.